To be able to talk about probability and later on statistics, we'll need to introduce a few terms. A random experiment is one whose outcome is, in practice, unpredictable. For example, you roll a die and record the number it shows, or maybe you draw a card from a deck of cards. It's important to understand that it is the unpredictability of the outcome that makes it random. Random isn't reasonless, and the idea is that if there's any uncertainty of the outcome, a mathematician would call it random. For example, let's consider the experiment. A 6-sided die is rolled, and the result, a number from 1 to 6, is recorded. This is random. Even though the way the die lands is completely determined by the laws of physics, we cannot in practice predict it. Or consider a jury trial. The possible outcomes are a defendant is found guilty, a defendant is acquitted, or a mistrial. This is a random experiment. Before the trial concludes, we cannot predict which outcome will occur. And in fact, that unpredictability is a good thing because if we could, why have the trial? Now, in any random experiment, there is a sample space that includes all possible outcomes. For example, the experiment flip a coin and record how it lands could have outcomes like the coin lands heads, the coin lands tails, a bird swoops in and takes the coin away. While the third outcome could occur, it's not a reasonable outcome, so we typically omit it from our sample space. For example, suppose a 4-sided die and an 8-sided die are rolled, and the numbers shown are added together. The 4-sided die can show the numbers 1 through 4. The 8-sided die can show the numbers 1 through 8. And if we add one of the numbers the 4-sided die can roll to one of the numbers the 8-sided die can roll, we get one of the numbers from 2 up to 12. So an event is a collection of some of the outcomes in our sample space. Now it's important to note, for a normal person, some implies more than one and fewer than all. But mathematicians are not normal people. Some is any amount between none and all. In other words, when we say some, we might pick nothing at all, and we could also pick everything. So, for example, the sum of the numbers shown when a 4- and an 8-sided die are rolled gives us the sample space from 2 through 12, and we could define a few events. For example, E, the event that the sum is even, well, we'll just pull the even numbers from the sample space. O, the sum is odd, we'll just pull the odd numbers from the sample space. And C, the sum is a composite number, we can just pull the composite numbers from the space. We say that an event occurs if one of its outcomes is the result of one trial of a random experiment. For example, from our previously defined events, if the sum of the two dice is 6, then the events E and C occur since 6 is an outcome in the event E and also in the event C. If the sum of the two dice is 7, the event O occurs since 7 is an outcome in O. If the sum of the two dice is 1, we should check our arithmetic because 1 is not an outcome in our sample space. And remember, our sample space includes all possible outcomes.